We'll just do a couple of derivative problems to dust off the cobwebs of power rule, quotient rule, product rule, chain rule, stuff like that for calculating these derivatives. So feel free with all videos, pause, try the problems out. If you get stuck, you can start the video and pause again when you're able. Just remember you have control over that, starting and stopping, to do as much independent work as you can as I work through these two problems. So the first one, I noticed that I've got the product of two different functions, and so I'm inclined to approach this with the product rule. So I'm going to call u x cubed, and that means if I calculate u prime, I get 3x squared. And likewise, I will make v equal to 2x plus 3 to the 1/2. And that means v prime is going to be 1/2 2x plus 3 to the negative 1/2, and then times 2. Don't forget that times 2, that's the chain rule, the derivative of the inside of the parentheses. And I'll just go ahead and simplify that. That's 2x plus 3 to the negative 1/2. But I'm going to leave it in that form. Okay, the product rule, hopefully we'll remember, is u prime v plus u v prime. If you get those backwards, it doesn't really matter since it's addition. U prime is 3x squared times our original v, square root of 2x plus 3, plus u is x cubed times v prime 2x plus 3 to the negative 1/2. Okay. All right, so this is the important thing that you can make it to here. From here on out, we'll do a little simplifying. Some people might do the simplifying a little bit differently, but I'm going to show you what I would do if I came across this problem here. And I noticed that there is a root 2x plus 3 kind of in both of these terms. So I'm going to approach this with factoring. And I am going to factor this term out of both of these things. So 2x plus 3 to the negative 1/2. For our first term of 3x squared, and here we just want to remember our exponent rules. 2x plus 3, when we multiply, we add our exponents. So up here we have an exponent of 1/2. So I want an exponent of 1 on that, so that when I distribute, I get the correct exponent of 1/2 plus x cubed. And that turns out to have been pretty nice because this interior is going to simplify pretty well. Distributing the 3x squared, we get 6x cubed plus 9x squared plus x cubed. Combining 7x cubed plus 9x squared. And then we don't want to forget this, which I'm just going to go ahead and move to the bottom since it's got a negative exponent, square root of 2x plus 3. All right, our second problem. For our second problem, I notice a fraction, so I might be inclined to think quotient rule, but I also notice this exponent. And when I look at the exponent, it's applied to the whole thing. So this looks to me like the derivative of some function raised to the second power. And that construction right there, that's a chain rule problem. I know what that equals. It equals 2 times that function to the first power times the derivative of that function. That's our chain rule. So I'm going to try and follow this pattern here. Now the first part is pretty straightforward. It's 2 times our function. Our function is 6 minus 5x over x squared minus 1 to the first power. It's the second part that's going to be a bit trickier, this f prime of x. Okay, so I'm just going to come over here and do that as a separate problem. The derivative of our f of x, so f prime of x is the derivative of f of x. We're trying to do the derivative of this fraction. And in this case, thinking quotient rule is going to be appropriate. U is equal to 6 minus 5x. U prime is equal to negative 5. V is equal to x squared minus 1. V prime is equal to 2x. And our quotient rule, u prime v minus u v prime over v squared. In this case, if you get the order mixed up, that is a problem since we are doing subtraction on the top. U prime is -5 times v is x squared minus 1 minus u 6 minus 5x times v prime 2x. I'll go ahead and simplify that and then put v squared on the bottom. -5x squared plus 5 minus 6 plus 5x. Well, I didn't distribute my 2x. Let's distribute the 2x into that. Minus 12x plus 10x squared. Combining here, we get 5x squared minus 12x plus 5. And then we don't want to forget our v squared. Our v was x squared minus 1, so I'm just going to put x squared minus 1 squared. You could square that out by foiling. You'll find that it's often not very useful to do that. All right, so we'll remember why we did all of that, and that's because we need to multiply up here by f prime of x, and I will bring that back in, times 5x squared minus 12x plus 5 over x squared minus 1 squared. Last thing we have to do is just simplify this, and you'll see kind of why it was useful to leave x squared minus 1 in its squared form instead of foiling it out. We'll just get, let's go and distribute this to 12 minus 10x times 5x squared minus 12x plus 5 over x squared minus 1 cubed. I don't see any value in foiling out the numerator, so I'm going to leave my derivative like that.